Okay, so welcome back, and now we're going to talk about something called the Pythagorean Theorem. The Pythagorean Theorem was developed by a famous mathematician a long time ago called Pythagoras. And what he did was he did a lot of work with geometry, and one of the things he found was this relationship between the sides of a right triangle. Okay, this is only for right triangles. Okay, and he found that if you square the legs, right, so you take the square of the legs and then add those squares together, you're going to get the amount of the hypotenuse squared. And so he came up with this relationship that works for all right triangles. Okay, so now, how did he discover this? Well, he discovered it by working with areas. Okay, what he found was if you take the length of this leg and you find a square, right, you form a square on that leg, so that means this side is also length B, right? And if you take the area formed by this leg, right, so we form an area, a square on this leg, okay, and so that means this side is length A. Well, what he found was that if you take this area of this square and you take the area of this square and you add them together, well, what happens is you end up with this area. Okay, something like that. And so again, we have that. So what he found was that for any right triangle, if you take the area of this square plus the area of this square, it'll add up to the area of this square, which translates into this formula, which is what we call the Pythagorean identity. Okay? And this is based on the Pythagorean Theorem. Okay? And so now, again, some of the identities, some of the other identities that are also equivalent to this is that you could solve this for example, C. So we know that based on this idea, C then would equal the positive square root, okay, because we're talking about areas, right? We're talking about positive square root of A squared plus B squared. But also, equivalently, we could solve this for B squared, right? So that would mean we could say that B squared is equal to, C squared minus A squared, right? Or we could say A squared is equal to C squared minus B squared. So equivalently, we could say, okay, well in that case, then we could say B is equal to the square root of C squared minus A squared. And we could also say that A is equal to the square root of C squared minus B squared. Okay? So then we get three other equivalent results from the Pythagorean identity. So we could get this, right? So we could use that to solve for C. We could use this to solve for B, and we could use this one to solve for A. Okay? But it all comes from this Pythagorean identity. Okay? Have a great day.